Hello everybody, it's time to start visiting our second unit in our matter section, matter, physical and chemical changes. Let's start with physical properties of matter. All objects are made of matter, but different objects have different physical properties. Physical properties are properties that can be observed or measured without changing the object, or changing any of its materials into something else. Some properties like mass and size can change according to how much of the substance is in it. For example, we see two oranges. They're both oranges. However, their mass and their size are different, but they're still oranges. Some properties that never change are natural color, smell, magnetic attraction, boiling point, and melting point. There are 5 observable physical properties for all matter. Texture, so how something feels. Malleability, ability to be bent or hammered thin without breaking. Ductility, the ability to be pulled into thin threads without breaking. Gold is the most malleable and ductile substance on the whole planet. It can be pulled into very thin, fine gold chains or fine jewelry. Density, we're going to be talking a lot more about this in class soon. Density is the amount of mass that fits into any given volume. Let's look at this example here with the ping pong ball and a golf ball. They're about the same volume, so that means they take up the same amount of space, but their masses are very different. The one with the greater mass will have the greater density. It means there is more mass packed into that volume than in the other object. The density equation is mass divided by volume, and again, we'll practice that more in class. Buoyancy is the ability to float in a liquid or rise in a gas. So as you see in this illustration, in the water, when you swim or when you're floating on top of the water, especially if you have your life jacket on, it's because the force pushing you up from the water is greater than the force that is pushing you down from the sky. This is called buoyancy, the ability to float. So speaking of will it float, before there was other late night show hosts like Jimmy Fallon, there was David Letterman, and every Friday night he would play a game show called Will It Float. So let's check an episode out.
Well, ladies and gentlemen, it's time to play Will It Float. Here we go. All right, Alan, what are we playing for tonight?
Dave, we are playing for a cheese log.
Cheese log. And what is the item that we're floating or sinking?
Dave, we're playing for a cheese log.
Yes.
The item is a cheese log.
Oh, I see. Well, I'm glad to see that it's not only me tonight. I'm having trouble making sense of nothing. All right, so what are we playing for, though?
Dave, we're playing for a cheese log.
We're not playing for a cheese log.
Yes, we are, Dave.
All right.
Make something up, Alan.
What is the item?
Dave, it's a cheese
No,
log.
it can't be. The item that we're floating or sinking cannot be the item we're playing for.
Okay, Dave, we're playing for a monkey.
Oh, good, that's
Back to you, Dave.
Yeah. You're happier now?
I feel much better.
All right.
A cheese log, and it's a fat cheese, got all that fat, it's got to float.
You say, but it's heavy. I say it's going to sink.
You say it's going to sink?
Yes.
All right, bring up the deal and let's play Will It Float. Here we go, ladies and gentlemen. Hi, girls. Nice to see you. How are you? Anytime, dump it in there.
Okay, so as we just saw, clearly a cheese log is not very buoyant. But there are lots of other objects that are buoyant, from something as small as a rubber ducky to something as huge as a Navy aircraft carrier on the ocean. Buoyancy doesn't just have to do with size, it has to do with density, and we will talk more about this in class. So now let's talk about physical changes. So changes that objects can undergo in a physical way. When a substance goes through a physical change, some of its physical properties may change, but it does not become a whole different substance. For example, check out this piece of paper. It's just a piece of paper. But then it gets ripped and torn and cut into tiny bits. The paper is now in lots of pieces, but it's still paper. Physical properties determine the changes it can undergo, but the atomic makeup stays exactly the same. None of the molecules have moved around at all. It's just in a different shape or a different size, but it is still paper. The opposite of physical changes are chemical changes. A chemical change is when a whole new substance is formed. The same atoms are present, but they are rearranged to make something new. So here we have oxygen and we have methane, and all of the molecules are broken apart and rearranged to make something new. So it puts off carbon dioxide and water. This is a chemical change.
Another term used to describe a chemical change is chemical reaction. In chemical reactions, one or more substances are changed chemically into different substances. There are certain clues you can use to recognize that a chemical reaction is occurring. For example, when you fry an egg for breakfast, it experiences a chemical change. It changes color. A color change is one clue that a chemical reaction is occurring. You observe. What happens to these tablets when you drop them in water? That's right, they bubble as they give off gas. Sometimes during a chemical reaction, gas is given off. Other times in chemical reactions, heat is given off. This occurs when wood burns. And sometimes in chemical reactions, light is produced. This happens when a glow stick is activated or a flare is lit. These are just a few clues that chemical reactions are occurring.
Okay, so a chemical change is a substance that changes that a substance can go through depend on its chemical properties. There are 3 of these we're going to talk about today. The first one is combustibility. That is its ability to burn. When a substance burns, the atoms or molecules chemically combine with oxygen, and the atoms get rearranged. For example, methane is a combustible gas made of carbon and hydrogen. And when this burns, the atoms separate. Then they combine with oxygen atoms to make 2 new substances, water and carbon dioxide. So here is methane burning. And here's the reaction that takes place, the same one I showed you earlier. It's kind of like a dance, but all the molecules change partners. So when you burn methane with oxygen, together they create carbon dioxide and water. All the molecules have rearranged to make something new. There are 2 more chemical properties. Reactivity. Reactivity is the ability of chemicals to go through a chemical change. Things that are reactive will go through it very easily. Stability is the tendency to not easily go through chemical changes, and they rarely react. So let's look at some chemicals that will react very easily.
Tickle, bring on the rubidium.
Here it is.
Is that it?
Well, it might not look like much, Richard, but it's a highly reactive metal. It's sealed in this glass tube under argon atmosphere conditions, just for safety.
Right, so what's going to happen when you drop that in the water?
Well, imagine, if you will, letting off a hand grenade in a bathtub.
Righto, I'm off. Have that.
Okay.
Good luck. Okay, Tickle. Drop the rubidium in the water.
Stand back, everybody. This one's going to be bad.
2 grams of rubidium will only react when our specially designed vial dissolves in the water, which gives John a few crucial seconds to get into our safety zone. Yes! Wow, that is more like it. Only on Brainiac do you get that kind of science. But
Like we could get through a science video without an explosion. All right, anyway, so that chemical that you saw them drop into the bathtub is this stuff called rubidium. Rubidium is one of our alkali metals. Everything on this side of the periodic table is super reactive. It has a high reactivity. On the other side of the spectrum, the other side has the noble gases. The noble gases are very stable. They have a high stability. There are several different types of reactions that chemicals and other matter can go through. Combustion reactions is any time a substance combines with oxygen to give off heat and light, like you see right here in this picture. This example is burning sulfur. A decomposition reaction is when a substance is broken down into something simpler. Like when electricity passes through water, it actually separates out the hydrogen and the oxygen. You've probably seen oxidation reactions a whole lot. They are often done by metallic elements reacting with oxygen. For example, when iron rusts, tarnish on silver, and when copper turns green. We can prevent chemical changes. The Declaration of Independence that is inside this case, it's preserved with pure helium, and it's stable and it won't react with the very old paper. Chemical changes are also things that spoil our food. Bacteria growth, those bacteria give off acids, and so that's why we refrigerate or freeze our food. The process of freezing removes heat energy and can slow down the change. It won't keep it good forever, but it'll keep it good for much longer. That's all I have for you today, folks. Have a great day, and thanks for watching.